Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. One of these mysteries is centered here, in the Grand Canyon in Arizona. Close to 1 billion tons of rock have been carved out of the ground. The canyon left behind could hold all the river water on Earth and still be less than half full. For more than a century, scientists have debated how and when this vast chasm was created. Geologists are uncovering fresh evidence of how the Grand Canyon, one of America's most spectacular natural wonders. A canyon 18 miles across at its widest point, 277 miles long, and more than a mile deep. It is so vast that it can even be seen from space. Although Hell's Canyon in Idaho is almost half a mile deeper, and Australia's Capertee Valley is nearly a mile wider, the Grand Canyon remains the most famous of them all. And it also holds one of geology's greatest mysteries. Just how did the Colorado River, only 1/10 the size of the Mississippi, form such a large canyon? The answer has eluded scientists for more than a century, because many of the clues they normally rely on have been swept away by the river's water over millions of years, or buried by landslides, or destroyed by volcanoes.
It seems like we should understand perfectly how the Grand Canyon formed.
So, nearly 2 billion years ago, before the canyon evolved, ancient mountains 6 miles above sea level stood here, towering peaks as high as the modern Himalayas. Over the next 500 million years, these mountains were worn away by the relentless forces of erosion. Over millennia, the freezing and thawing of ice cracked open the rock of the mountain slopes. Wind and water carried the rock debris down towards the oceans, leaving behind a flat and featureless plain with no sign at all of a canyon. Many different layers in the walls of the Grand Canyon tell Karlstrom that over hundreds. The last time this part of Arizona was under the sea was around 80 million years ago.
As we go higher in the layers in the Grand Canyon, we have different age seas which are depositing different kinds of rocks, different environments, different fossils that live at the...
The next puzzle for geologists is uncovering which awesome forces transformed that unremarkable flat land into this breathtaking natural wonder of the world. From 1.7 billion years ago to 70 million years ago, the landscape of western Arizona, it's clear that this region underwent a type of geological disturbance that pushed up the entire seabed. Geologists discovered in the 1960s that collisions between separate plates of the Earth's crust could force land up into the air. It happens all over the globe and usually deforms the land into tilted mountain ranges. But this Arizona uplift was unique.
After all the flat layers are deposited in that sea level,
the high plateau was surrounded by even higher mountain ranges. New rivers began flowing from the mountains out across the plateau. It's essential for the investigation to establish when the Colorado River in particular arrived, because only then could it begin to carve the canyon. Until a few decades ago, believed that Hindu Canyon's creation, 50 million, but in 1969, the discovery of these pebbles turned everything that geologists thought they knew about the canyon. His professors sent him to investigate Hindu Canyon. But when Young arrived at the dusty riverbed, he discovered that it had no Colorado River could never have flowed to Young's right. It has always run in the opposite direction, towards the Pacific Ocean. The river here, 50 million years ago, was not the Colorado. Young's findings meant scientists had to rethink all their ideas about when the Colorado had arrived on the plateau and about the age of the canyon. They started examining evidence from another, less ancient site. This is Muddy Creek, near Lake Mead, Arizona, just a few miles downstream from where the underlying rocks prove that this was once the site of a vast freshwater lake.
The upper part of the limestone is not compatible. The animals and plants that live in such a lake can't exist if there's a lot of silt and mud in the water.
So, the muddy death of the lake gave geologists a confirmed date for when the Colorado arrived in Arizona and commenced its excavations. The Grand Canyon was born a mere 5.5 million years ago. The investigation has reached a significant milestone. It has discovered the age of the canyon. Now geologists had a new mystery to solve, discovering why the Colorado River took the path it did some 5.5 million years ago, and why it carved a canyon of such remarkable dimensions. To the Colorado Plateau. 5.5 million years ago, the Colorado River began carving out the Grand Canyon from this plateau. The question scientists now had to answer was what happened at that time to cause the river to dig deep and carve out the canyon. It is a debate that has been going on for more than a century and which continues today.
I got interested in the Grand Canyon when I went to school and started studying, and I heard about the different ideas associated with the Grand Canyon and was just blown away when I found out we did not understand how the Grand Canyon formed. Something as iconic as the Grand Canyon wasn't understood, just seemed crazy to me, and so basically decided to dedicate a large portion of my life to trying to figure it out.
One theory is that several ancient rivers merged and their combined cutting power started digging out the canyon. Another assumes that the river cut down into the plateau as the land uplifted around it. But John Douglas has his own theory, one that has gained respect among many leading geologists since he first published his ideas in 2000. What Douglas calls his spillover theory seems to work well on paper.
Spillover is incredibly easy. All it means is the Colorado River poured into a basin. When it poured into that basin, it had to form a lake. And this lake was huge. All that lake had to do was rise and then spill across the plateau. It poured down, cutting rapidly, and over time you would have ended up with the beginnings of Grand Canyon very quickly.
At his college campus in Phoenix, Douglas is building a scale model experiment to see if his spillover theory actually works in real life. He sculpts tons of dirt into a model of the Colorado Plateau. Running faucets represent the flow of the Colorado River into the ancient lake.
Now we have our large lake. The water's getting higher, it's getting ready to spill across. We have a tiny little trickle of water pouring down off the lake. That little tiny trickle of water doesn't seem like much, but over time, that little bit of water flowing down that steep slope is going to gain energy. It's going to start cutting, making waterfalls that work their way back. One waterfall has now reached the lake. You can see that we have just released a significant amount of water, much more water than was previously pouring down. Now we have huge canyon cutting. Landslides are sloughing off the side of the canyon walls, the water flushing it downstream. The lake, you can see that it's starting to shrink in size. That lake is getting lower. And right there, you can see that we have cut our own small-scale version of the Grand Canyon.
Douglas's experiment proves that the spillover theory works in miniature, but he needs evidence to show that it could have happened on an infinitely bigger scale. Douglas sets out in search of a lake large enough and old enough to be the source of his spillover flood. He has a prime suspect in mind. This is the site of the ancient Lake Bitahoche, 100 miles to the east of the Grand Canyon. And a clue here on the old lake bed reveals how deep this lake once was.
These green clays, which indicate deep lake water, this is the classic evidence for the giant lake necessary for the overflow explanation of Grand Canyon.
These green deposits are only created in one specific environment.
To have green lake clays, you need deeper water where there is little oxidation. I think that's indication that the Colorado River has arrived in this basin, that it's made its way from the Rocky Mountains to this location. And this is its basically stopover point before it eventually spills across to form the Grand Canyon.
Establishing the depth at this point lets Douglas work out how large an area was once covered by water. He compares the depth of the water with the contour height lines of the surrounding countryside. And that shows that Lake Bitahoche once spread over 20,000 square miles and contained more than 3,000 cubic miles of water. That makes it bigger than Lake Michigan. Douglas needs to date the age of this lake. For his spillover theory to work, it has to be older than the Grand Canyon, more than 5.5 million years. He unearths the proof he needs in these deep water fossils.
Okay, these fossil shells are freshwater mollusks, maybe as young as 6 million years old.
The dates match up. The lake was here at the right time to have spilled over and begun cutting the Grand Canyon. Dating the fossils helped confirm Douglas's belief, but his search for more evidence continues.
In reality, we're never going to know how it formed to 100% certainty unless someone builds a time machine. By doing this kind of work, all you're trying to do is increase your level of confidence on your ideas, build up your case, build up your evidence.
Building up his evidence is exactly what Joel Pedersen is doing. He is using the very latest technology to prove exactly how fast the Grand Canyon was carved. He has found the evidence he needs right here, at the very start of the Grand Canyon.
Here at Lee's Ferry, there are all of these gravels that are evidence of where the river has been in the past and the path that is taken during incision. And amongst the gravels, sometimes you see these great lenses of sand, and we can use the sand to get an absolute date on these deposits.
As the Colorado River carved out the canyon, it deposited more and more of the gravel and sand debris at this spot. Newer layers buried older layers over millions of years. And geologists now have instruments that can measure how light has affected individual atoms within the sand. That reveals precisely when each sand layer was originally buried, away from the light of the sun. For the technique to be accurate, it's essential that the sample is not exposed to daylight.
So here we can take a metal tube and we can hammer it into the sand outcrop, and in the metal tube then we'll get a sample of the sand and it'll stay out of sunlight, and then we take it back to a darkroom laboratory and remove the sand still sheltered from light, and then we can analyze the optical properties of it to get an absolute age. And in this case, the absolute age would tell us when the river was at this point in the landscape.
Back at the lab, Pedersen compares multiple sand samples, each from a different depth in the canyon deposits. Discovering the age of each individual layer of sand lets him estimate how rapidly the river has been cutting down through the rocks.
here at Lee's Ferry, we can use this last 500,000-year history along with our absolute dates and all the information we get. And the rate of canyon cutting here is about 1,000 feet per million years.
That's 1 foot in every 1,000 years, a little more than 1 inch every century. It proves that the entire 5,300-foot deep Grand Canyon could have been cut in a little more than 5 million years. In geological terms, the mere blink of an eye. The investigation is assembling evidence on how the Grand Canyon was created. Green clay deposits support the theory that an ancient lake was big enough to spill over and trigger the canyon's creation. Deep water fossils prove that the lake existed 6 million years ago, the right time to have overflowed and cut the Grand Canyon. But proving how the canyon cutting began is only part of the investigation. This is one of the widest and deepest canyons in the entire world. And to discover how it grew so large, geologists will have to examine some of the most dramatic and dangerous features the canyon has to offer. The landscape of western Arizona has transformed from ancient mountains to prehistoric seas to a flat, uplifted plain. Just 5.5 million years ago, the Grand Canyon was cut through this plateau. It happened so fast that geologists had to think again about the awesome power of the Colorado River.
It cuts through rock not by the water wearing it away. You could pour water over rock for a long time and nothing would happen. It's the tools that the river carries. The river carries boulders and sand, and those bump against each other and they eat away at the rock.
Every day, the Colorado can carry almost 500,000 tons of rock and debris, enough material to fill more than 100 Olympic swimming pools. That is 5 tons every second. So investigating river erosion is never an easy task, because the powerful flow of the Colorado River has scoured and washed away many of the clues that the rock detectives need. They looked for evidence in the hundreds of rapids that disrupt the river's progress. The swirling rapids are created when flash floods sweep boulders into the river from the many smaller side canyons.
The river has to focus a lot of energy at these points to deal with all of the boulders that are coming in. The more coarse boulders and more resistant material that the river has to fight against to accomplish its incision, the steeper it gets.
As the water flows over the rapids, it cuts deep into the bedrock below. At this set of rapids alone, the river drops 10 feet. And there are a lot of rapids on this section of the Colorado.
So put all these rapids together in a string through Grand Canyon, and that gives you the overall sort of unusually steep Grand Canyon profile of the river going through it.
Gravity and simple physics are at the heart of how the Colorado has carved so much rock so quickly. 5.5 million years ago, the Colorado River was flowing over the steep edge of the plateau that had been pushed up thousands of feet above sea level. The river ran rapidly over the steep downward slope and swept rough, rocky debris along in its wake. An incision formed, digging back into the edge of the plateau.
The power of the river to incise as it dropped off that huge escarpment must have been really great. And so the river quickly incised there, and that very steep drop-off of incision would have worked its way back upstream through the Grand Canyon region. It's sort of a waterfall that a few million years later has spread itself out through the length of the river.
It is this steep drop-off between the Colorado Plateau and the land beneath it that fuels the Colorado's incredible erosive power. The river begins its life high in the Rocky Mountains in Colorado. For every mile that it travels, the river falls 10 feet. By contrast, the Mississippi River, a river moving 10 times as much water as the Colorado, meanders across a flat landscape. With no steep slope to drive it, the Mississippi can't carve any canyon. But the Grand Canyon is not just steep, it's also wide. And here, on the South Rim, at the heart of the national park, the true majesty of the Grand Canyon is revealed. This is where the canyon is at its widest, as much as 18 miles from rim to rim. This landscape appears serene now, but its unique beauty was forged by violent forces.
Grand Canyon, oftentimes we just associate it with the Colorado River. The Colorado River is what cut the Grand Canyon. It formed the initial gash to allow the river to flow across. But what makes Grand Canyon grand is really its width and all the layers of rock that are exposed. And that isn't only solely tied to the Colorado River. What's happening is this rock that's exposed, it's being beaten on by rain, and the rain gets in there and it weathers the rock and it weakens it. And then because this is so incredibly steep, gravity will act on that material, transporting it deeper down into the river, flushing it back out. And that process just repeats over and over again to allow the canyon to get wider over time. We have classic rock falls that are cascading down onto the black rock in the far distance. Those events are indications that this is actively ongoing canyon widening and retreating from these processes.
The fall of these rocks is not a gradual process. This is erosion at its most violent.
Very few people are ever going to see Grand Canyon actually change. Like, I've spent numerous nights in Grand Canyon, and I've only heard 1 or 2 rocks ever fall. But change will happen, and when it does happen, it happens very rapidly.
The rocks fall because both harder and softer rocks are layered, one on top of the other, in the canyon walls. The harder layers are made of limestone and sandstone. These rocks don't weather easily. But the softer shale beneath is made of mud that expands when it rains, causing the shale to crumble away.
Those weaker rocks, they weather and retreat back, and they undermine the resistant cliff rocks above that will then fail as dramatic rockfall landslide events, allowing the canyon to increase its width.
The rock falls are merely the first step towards increasing the Grand Canyon's enormous width. Without the help of an accomplice, the entire canyon would fill up with debris.
Without the Colorado River, you could not have the Grand Canyon as wide as it is. By flushing that material downstream, it wipes it all clean to allow a whole new material to build up again. And once you repeat that over and over again, it allows the canyon walls to retreat back. And the entire canyon just grows. These guys continue to march and push and move all that material downstream.
The mystery of how the Grand Canyon grew so deep and so wide is being solved. The Colorado Rapids demonstrate how the steepness of the riverbed helps carve the canyon so quickly. Rock falls on the canyon walls reveal how weaker rocks rapidly widen the canyon across the plains of Arizona. But this is far from the end of the Grand Canyon story. In just the last million years, the canyon has been transformed by other, overwhelmingly powerful natural forces. Geologists have established that over 1.7 billion years, the Grand Canyon emerged from ancient mountains and prehistoric seas to become one of North America's geological icons. This is a rare look at one of the most remote and secret parts of the Grand Canyon. A series of small cone-shaped mountains line the canyon's edge. And there are flows of black rock running down from each rim. They come from a remarkable era just 725,000 years ago, when the peace of the canyon was shattered by volcanoes. This is Toroweap Point, in a remote area known as the Arizona Strip. One of the most isolated places in the continental U.S. Few people other than geologists ever see this area, although it boasts some of the canyon's most stunning views. The rock detectives come to see how explosive volcanic eruptions have changed the canyon in the comparatively recent geological past. This black rock that seems to have spilled over the rim of the canyon is an ancient lava flow, what was once boiling hot rock, forever frozen in time.
Powell talked about a river of molten magma pouring down into a river of melted snow. And he talked about how dramatic it must have been, the boiling and seething and the steam, and it must have been amazing. You would picture red hot lava like you would see in Hawaii pouring down the canyon walls and coating them. And then once it reached the river, it would it would immediately create just giant clouds of steam.
The extensive lava flows, erupting from as many as 100 cinder cone volcanoes, had a dramatic effect on the Colorado River running below. Crow believes that on at least 8 occasions, the volcanic eruptions created huge lava dams that blocked the river completely.
Well, behind me here is one of many basalt remnants. They're the remains of lava flows that poured down the canyon, partially filling it. And then subsequently, the Colorado River has removed all but a few little chunks.
The lava dams brought even the powerful Colorado River to a halt. For a while. In time, the dams were no match for the Colorado. The rising pressure of the dammed river behind them eventually became too much, and they shattered. This explosive episode has left its mark on the canyon's walls. Today, the cones appear to be extinct and lifeless, although some geologists believe that the volcanoes might not be finished quite yet.
The last eruption that sent lava pouring into Grand Canyon probably occurred about 100,000 years ago. There is evidence for an eruption on the rim that didn't actually make it into Grand Canyon that's 1,000 years old. So there's I think a good chance that in the future there may be eruptions here as well.
The Grand Canyon's future has yet to be written, but investigators now understand the story of its past. The calcium in the garnet discovered at the base of the canyon reveals the ancient beginnings of this landscape, an immense mountain range. Limestone rocks show that the canyon was only formed 5.5 million years ago. Green clays that can only form in deep water prove that a huge lake, bigger than Lake Michigan, could have been the trigger for this canyon carving. And rock falls from the crumbling cliff faces of the canyon rim are evidence of how the canyon grew to the shape it is today. Geologists have been studying the canyon since the mid-1800s. Yet even after more than a century of investigation, the story is still far from finished.
The landscape is evolving and it's going to be changing through the geological future. And so the story about the geology and the fascinating questions here is not one that's over, and it's going to continue to evolve as scientists continue to do work here.
The dynamic geological phenomenon of the Grand Canyon is a place where the vast fiery forces within the Earth's crust do battle with the inexorable power of water. The result? A natural wonder whose walls record nearly 2 billion years of our planet's turbulent geological history.